Yes, I'm Javier Gonzalez from the Department of Health. Sorry for being a little bit late there. I was just finishing examining a PhD, which was in relation to what I'm going to be talking to you about, which is carbohydrates for endurance exercise. Now, carbohydrates are an important fuel source during almost all types of exercise, and we store our carbohydrates predominantly within our muscle as something called glycogen. We also store some of that glycogen in our livers, and then we have some glucose circulating in our bloodstream. And if we add all of these up, they can provide, at the very most, 3,200 kilocalories of energy. And that's not very much to sustain prolonged exercise. And when we deplete our muscle and liver glycogen stores, that's associated with early fatigue. But what we can try and do to prevent this is ingest additional sources of carbohydrates. So we can drink sports drinks. If we drink glucose, then the maximum rate at which we can digest, absorb, and use that as a fuel is around 1 gram per minute. But if we ingest different types of carbohydrates, such as glucose and fructose, then we can elevate that rate at which we can digest, absorb, and use that carbohydrate as a fuel source by almost twofold. Now, sucrose is another type of carbohydrate, also known as table sugar. And interestingly, this is comprised of both glucose and fructose molecules. The other interesting thing about fructose is it seems to be preferentially taken up by the liver. So we wanted to know, what is the effect of carbohydrate ingestion on the depletion of liver and muscle glycogen? And if we ingest sucrose in particular, does that make a difference? So is there any beneficial effect in particular with the liver? Now, usually when we look at muscle glycogen, we literally cut a piece of muscle out and measure how much glycogen is there. And we didn't really understand why the cyclists didn't want their livers cutting out. So we decided to employ a technique called magnetic resonance spectroscopy. And here you essentially adapt an MRI scanner. And here you can non-invasively determine the glycogen concentration in both the liver and the muscle of living human volunteers. So we took cyclists, we brought them into the lab, and they had this MRS scan. They then cycled for 3 hours at a moderate intensity, during which time they ingested 3 different drinks. So it was either water, glucose, or sucrose, which has this mixture of glucose and fructose. We took regular blood samples throughout that exercise, and we collected samples of their expired breath where we can determine whether they're burning carbohydrates or fats during the exercise. Immediately after exercise, we took another scan where we were able to determine the depletion of these glycogen stores in liver and muscle. So what did we find? Well, in terms of muscle glycogen, if you don't ingest any carbohydrate during exercise, then you see a depletion of about 40%. If you ingest glucose, then that doesn't seem to influence this. So we still see a 40% depletion in muscle glycogen with exercise. Similarly, with sucrose, no difference in muscle glycogen depletion. Not very interesting. But the liver was where something really happened. So in terms of water, we see another 40% decline in liver glycogen with exercise. But if we ingest glucose, we completely prevent liver glycogen depletion. If we ingest sucrose, then we see a similar response. So sucrose and glucose both prevent liver glycogen depletion during exercise. But sucrose is achieving that without producing so much gut discomfort. So we're asking these cyclists to ingest a lot of carbohydrate during exercise. And they start to get a bit of gut discomfort, particularly towards the end. But if they're ingesting sucrose, then this gut discomfort is lowered. So there are some potential benefits to sucrose over glucose alone. And in addition, their perception of effort during that exercise was also lower with sucrose. So from this, we can conclude that if you're ingesting ample carbohydrates during this endurance-type cycling exercise, then carbohydrate ingestion can prevent liver glycogen depletion. And it doesn't matter which type of carbohydrate you're ingesting, whether it's glucose or sucrose in this regard. However, sucrose can achieve this effect with less gut discomfort relative to glucose.